Hey YouTube, this is my fourth video in my module on geometric sequences. In this video we're going to focus on adding up the terms of a geometric sequence. In other words, a geometric series. Okay, so we'll talk about the rule for finding the nth term of a geometric series in just a moment. Let's talk about what a geometric series is. So if you take a look at this first geometric series we're going to be working with, essentially you can see that this is geometric to begin with because you see that from 1 to 5 here we took it times 5. We say also we take 5 times 5 to get 25 times another 5, we get this here. We have this geometric pattern where each thing, if you were to take each term like 625 and say divided by the term before it, 625 divided by 125 is 5. You keep getting this common ratio. So things that are a geometric series, basically it's a geometric sequence where we're adding together the terms of the sequence, okay? So maybe we want to find the sum of the first 10 terms of the sequence, or the sum of the first 20, or sum of the first 100. We can actually do this by using this formula up here. So we say, all right, just as with other series such as arithmetic series, we have a rule for finding the sum of the first n terms of the series. So we'll call this rule sum s sub n, okay? And so what this stands for is the sum of the first n terms, okay? Where we have a common ratio that's not 1, is always given by this. So in terms of when I want to find s sub n, there are a few things we're going to need. So we say need. What are the things I need? We need a1. So we say first term, is one thing we're going to need here. We're also going to need n, which is the number of terms. We're also going to need r, which is our common ratio. Okay, so knowing these things, we can actually go find the sum of the first n terms of this sequence or this series. So, for example, this first geometric thing we see here, we want to go find the sum of the first 10 terms. We're going to write S10. And so according to our formula up top, it is A1 times, now 1 minus r to the nth, where n in this case is 10. Okay, and this is all over 1 minus r. So now we just need to finish this up. Thing is, we actually know what our first term is here. Our first term is 1. We say A1 is 1. And then we say, well, I need to know R. Well, the R thing here is this common ratio. We notice it was 5. It was multiplying by 5 every time. So to go ahead and finish this out, we say, well, what would happen if I added up the first 10 terms in this sequence that we see up here? Well, we get A1, which is 1, times 1 minus now R, which is 5, to the 10th power, which is our n, all over 1 minus 5. And so this is our sum right here. We do need to clean this up. So we get 1 times anything is itself, so I'm going to neglect this 1. And on the top up here, we get 1 minus 5 to the 10th over 1 minus 5. Over the top and the bottom, it's a lot easier to go ahead and complete the operation on the bottom. On the top, you actually have to get a calculator out. You have to say, well, 5 to the power of 10. And we say 1 minus this. So we say minus 1 here. We actually get this. We say 9765624. 9765624. Except for 1 minus what we did, we'll leave this negative, okay? And so we need to actually come up with a number for this. If we take on our calculator, divided by negative 4. Now I'm going to keep that 4 positive on my calculator, but I get 2441406. So 2441406. That would be what I get when I take this divided by this. So we say this is the sum of the first 10 terms. You notice it's rather big, but I mean, if you look at your sequence up here with 1 plus 5 plus 25 plus 125 plus 625 just for the first 5, and then you're going to be taking the rest of them times 5 each time to find the next 5 terms. So, it's a big number. Let's try this again. If we have a different geometric series, we want to find the sum of the first 10 terms. So we want S10. So we need A1 times 1 minus r to the, in this case, n, and n is 10, over 1 minus r. So now we need first term, so good news, we have our first term here. We say a1, a1 equals 4. Now r, we need to find r. Remember, r, we can always find r by taking a term like 2 and dividing out the term right before it. So 2 divided by 4, which is a half. In other words, we keep taking this, each term, times a half to get the next term. So times a half, times a half, times a half, okay? So r is a half in this instance. So knowing these things, let's go ahead and plug in what we know. We say the sum of the first 10 terms would be our first term. So our first term here is 4 times 1 minus r. So we have a half to the 10th power, all over 1 minus a half. There's our r down here. So we're actually going to have to take a minute to think about this one here. We say 4. Now, top and bottom, again, it's a lot easier to do the bottom than it is to do the top of this fraction. So 1 minus a half is a half. We get a half on the bottom. Up top we have 1 minus a half to the 10th, where we have to do our half to the 10th first order of operations, and then take that away from 1. So we say, look, if I took 0.5 to the power of 10, I get a really small number, okay? So, and what we said was, we'll take this away from 1. What if I take 1 away from it? And then we'll just call it positive. So we get on top, we get approximately 0.9990234. 0.9990234. We'll take that divided by a half now, and we'll take that times 4. So we get this answer on my calculator. We said we were going to take this, we're going to divide it by 2, or divide it by 0.5, by a half. We'll take this times 4. So what we end up getting is about 7.99-ish. So we get approximately 7.99-ish. So now for the first time you've seen a series add up to a decimal, but keep in mind we were adding up fractions up here. So I just want to try this again a couple more times, but I want to use this notation instead, and this is sigma notation. Now recall with sigma notation, it's basically saying this. I want you to add up starting with this term, so like your first term, out to some term, we say the nth term, of some rule. In other words, the rule is telling you how to find all the terms in the sequence, and this is like saying, I want you to start here at this term and end at this term, but add up those terms of this sequence right here. So what I want to point out is this. This really is something that is geometric that you see right here, except for we have an I instead of an N. But this is A1 times R to the N minus 1 of the I minus 1, where our A1 in this case is 4, and our R is going to be this 3 halves. So when you see this right here, it says, I want you to add up this rule. I want you to add up the first term to the 12th terms. Go find terms 1 through 12 and add them up. What we could do instead is we could say, well, you know what? This is the sum of a geometric thing, and I'm adding up the first 12 terms of it. So let's go find S12. So we say our rule is A1 times now 1 minus R to the nth, where n is 12, so 1 minus R to the 12th, all over 1 minus R. And so now we need to know a few things about this rule, like what is A1? Well, A1, let's try this again. A1 equals 4. We can see this clearly here. We say R equals 3 halves. And so what we end up with is this. We say S12 is equal to 4 times 1 minus 3 halves, R to the 12th, all over 1 minus 3 halves. So let's go ahead and start cleaning this up. We say, well, in terms of this fraction, it's been easier to do the bottom first. 1 minus 1.5 is negative a half, really is what this is down here. And then 1 minus 3 halves to the 12th. You know, here's how I would type this into my calculator. I'd start inside out. Really clear everything out here, clear everything out there. We say 3 divided by 2. So this is our 1.5 here. We're going to take it to the 12th power. So we say to the power of 12. And I want to take this away from 1. So what I'll do is I'll take 1 away from it, and I'll switch its sign here for us. So we get this on top, negative 128.74-ish. So we say negative 128.74-ish. Okay, so we get now on our calculator that negative 128.74, oops. We're going to take it and divide it by negative a half. So we say divided by 0.5 negative, and I get 257.49. So now we need to take everything in here, take it times 4 on the outside, so times 4. And so we get this sum right here. We say approximately 1029.97. So 1029.97-ish. Okay, so you're going to have to deal with fractions. And then, you know, we'll talk about one more here. I do want to look at this one. This is a geometric thing where we have an A1 times an R to the K minus 1. I'm going to write N minus 1. But I want to point this out. Our R in this case, R is 2. Our A1 is actually this number out front here is 1. Okay, so our A1. We say A1 is 1, R is negative 2, but what we're trying to find is the sum of the first 12 terms. And I can tell you this here, we started at 1 and we went up to 12 of this rule. So we say S12 is A1 times 1 minus R to the nth, in this case n is 12, over 1 minus R. So we'll just go ahead and find S12. We say first term is 1. Whoops. 1 minus R, in this case R is negative 2 to the 12. All over 1 minus a negative 2. And it is important to use parentheses, because if you can see what I see here, we get this. We basically get on bottom 1 minus a negative 2, which is plus a positive. We get 3. And on top we have 1 minus negative 2 to the 12th. We actually have to do negative 2 to the 12th first. Okay, we have to do our exponents first. So we say 2 negative. I want to take this to the power of 12. So 4096 right here. We say 1 minus 4096 would be negative 4095. So we have negative 4095. And so now we need to take this divided by 3. So we say divided by 3. And we get negative 1365. And this is actually indeed what you get because you're adding up a bunch of negative terms each time. Okay, so that's how you find the sum of a geometric series.